Okay, what I've decided is I'm just going to record the 5 proofs that we worked on in class. Yeah, I decided on this just because, well, I guess hopefully it'll help you guys. I don't even know if you guys are going to watch this, but it's okay. Also, I don't know whose pen this is, or pencil. It's a nice pencil. I can give it back, whoever's pencil it is. But anyway, let's begin. So, this proof. Given AB is congruent to BC, BD bisects AC. Okay, so first what I see is AB is congruent to BC. So what I'm going to do is I'm going to write the given AB is congruent to BC. We also know BD bisects AC. So BD bisects AC. So this is our given. And our second one is also our given. So let's go and mark certain things. So AB is congruent to BC. We know segment AB is congruent to segment BC. Because these are congruent to each other, we have identified sides that are congruent to each other. They're a pair of sides. Next, okay, so BD bisects AC. So the key word here is the word bisects. So I see a lot of you getting mixed up with your terminology here. If it's not given that you have perpendicular lines, if there's no midpoint, if you only see the word bisects, you can only say definition of bisector. I don't want to see definition of midpoint or all those other crazy things that you're assuming. But okay, here. Keyword is bisects. So BD bisects segment AC. So segment AC is this one. Bisects, meaning it's splitting segment AC into two congruent parts. Two congruent parts. Okay. So AD is congruent to DC. Okay. Right. So what this means is, since it bisects, what we have here is this is definition of bisector. Okay. So here we proved that two segments are congruent to each other. Therefore, these pair of sides are congruent. Okay. Next, what we want to look out for is a pair of sides that are shared between both triangles. Our goal is to prove that triangle ABD is congruent to triangle CBD. So, the side that is shared between both triangles is segment BD. So BD is congruent to DB, and you can say this is by the reflexive property. Okay? So here, reflexive property says this segment is congruent to itself. So here we identify a pair of sides that are congruent. Okay. The final step that we're missing is here. So triangle ABD is congruent to triangle CBD. I see a lot of you getting mixed up with the reasons and everything. So if you see that triangles are congruent to each other, I only want to see side, angle, side, 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 angle, side, angle, or hypotenuse leg. I do not want to see CP-CTC. If we use CP-CTC here, it's going to be wrong. CP-CTC should only be used if you're proving sides are congruent or angles that are congruent. In this case here, we identified certain pairs of sides that are congruent. If I have to redraw this, for you guys to see this. This right here. Okay, so these triangles are going to be congruent to each other by side, side, side. Okay, all right, this is proof 1 of 5.